Okay, we're going to be discussing the IEB assessment matters, National Senior Certificate Examination 2016 past paper. This was pretty much a very standard mathematics paper too. So let's just discuss it because
Hi,
that's what is
Seth.
coming. Yes, please.
Hi, Seth.
Yes. Hi, Marang. How are you?
I'm good. How are you, Seth?
Yes, please. Okay. Yes, I under. Yeah, you went through this paper, did you? Yeah, I would imagine yesterday you tried some questions.
Yes, Seth.
All right. I was just thinking we go through this paper, then we can do more things today, tonight, after your brother, you know, because yeah, I'm gonna see your brother after 4:30. I'm just gonna set the time. So yeah. So yeah, if I'm gonna see your brother after 4:30, maybe at 5, I can see your brother. Okay, I'm gonna see my time is, let me see. Yeah, say at 5, I can see your brother. Yeah. Right. So okay, let's get started, guys. And then after your brother, then we can do other things. You can suggest it to me or I'll suggest to you. After this, I'll give you like more problems to try. Okay. IB Assessment Matters, National Senior Certificate, November 2016 is what we're discussing. Mathematics paper 2. We're going to do as many questions as possible. We can schedule other sections as well to do today evening. But my plan today is to do all the questions that have to do with the geometries, analytical, trigonometry, and Euclidean. We're getting started. Right. So this page was left blank deliberately. I loaded the whole paper. So we have like the full question paper. And this is section A and this question one. And question one is about in the diagram below straight line AB makes an angle of 135 degrees with the y-axis. Okay, we'll just run through all the questions, please. I know that sometimes you have more interest in others than others. You know, you think, okay, it's best to do this and that. Right, AB cuts the y-axis at A. So here's AB, it cuts the y-axis at the point A. B is joined to C. So B is joined to C. Right, a point on the x-axis. Here's a point on the x-axis. So that BC is parallel to the y-axis. BC, here it is parallel to the y-axis. Explain why ABCO is not a cyclic chord. Explain why ABCO is not a cyclic chord. Obviously, there are a couple of reasons actually pertaining why this is the case. And we can see that actually the angles that are opposite, for example, you can look at the fact that this angle here is opposite this angle here, which is actually 90 degrees. This one here is parallel to the y-axis. And therefore, the opposite angles, if you add them up, you need to get 180 if it's a cyclic quad. But surely you can see that actually this angle here plus this angle here is not 180 degrees. Because if this sum was actually 180 degrees, then this would have been 90 degrees because 90 plus 90 is 180 degrees. So the opposite angles do not add up to 180 degrees. That's what we write down and we say, what is the reason? We say opposite angles. Right, we say the opposite. The opposite angles do not, do not add up to 180 degrees. So the opposite angles do not add up to 180 degrees. And that is basically the reason why this quad here, um, ABC O is not a cyclic quad. Next question. If OA is 8 units, determine the equation of line AB. OA is 8 units. Right, so if we have OA and OA is actually 8 units, like that, we need to find the equation of line AB. Okay. Right, an interesting question though. Right, so so now the question obviously becomes, what is the angle of inclination of this line with regards to the horizontal? So you need to partition like this, and therefore be able to measure the angle that is from here to here. Obviously, this angle, okay, this will be like what takes the position of sort of the x-axis, so that this angle is 90 and this is 45. Okay, so if that is true, you could therefore have that this one is 45 degrees, and therefore the tangent of the line AB, the gradient of the line AB is the tangent of the angle of inclination, how inclined the line is to the horizontal, and therefore we shall say here clearly the gradient of AB is the tangent of the angle of 45 degrees, and the tangent is 1, so we got the gradient. Okay, if we got the gradient, we just need a point. We need a point. So what are the coordinates of A? Okay, we already know a couple of things, like we already know that this distance here is actually, the length is 8 units, so that the coordinates are 0 and 8 respectively. And therefore the line AB, whose equation we want, passes through the point 0, 8. So we are dealing with a line that is passing through the point A whose coordinates are 0, 8. Right, so which means you have y minus y1 equals m into x minus x1. So you have x1, y1, x1 here, y1 there. So it's y minus y1 is 8. The gradient m is 1. And therefore this is x minus 0. And therefore, if we finish off here, okay, this is 1 by x is x plus 8. It's x plus 8. So exactly what we have to obtain. So we have to find the equation of the line AB. And so now this is actually the line AB. We know that the line AB passes through the point A whose coordinates are 0 and 8. And the angle of inclination is actually equal to 45 degrees. Okay, if OC is 6 units, determine the equation of BC. OC is 6 units. Right, so we're looking at OC. OC is 6 units. Okay, if OC is 6 units, determine the equation of BC. Then determine the equation of BC. Okay, what is the equation of BC here? Okay, if the distance from here to here is 6 units, it means the coordinates of the point C are 6 and 0. And therefore, this would be x equals 6. So that in the end, then we have that the equation of the line BC is x equals 6 units. Okay, x equals 6, because x equals 6 will be the vertical line that passes, that is actually perpendicular to x-axis, passing through the point C of coordinates 6 and 0. Next, we need now the area of OCBA for 3 marks. The area of OCBA. Let's look at the area of OCBA. Right, if you look at the area of OCBA, what is the area? Right, so this area here, we can note a couple of things, like what are the coordinates of the point B at this point? What are the coordinates of the point B at this point here? Right, we know a couple of things, like we already know that the x coordinate of B would be what? The x coordinate of B would be the same as the x here. X is 6. What is the y coordinate? The y coordinate therefore would be what then we are able to get, because we already know the equation of the line AB. So it is x plus 8. So if x is, you want to get y, so substitute x here. So it's going to be 6 plus 8, which is exactly what? 14. So which means the coordinates of B are exactly 6 and 14. And we know to write, obviously, the answer. Please, guys, in the exams, you need to write something. Don't stare at the question and write nothing. Because if you write something, you get part marks for the attempt. You are making the effort, and the examiner is going to look at what you've written, not what you were imagining and did not even write down. So you can be excellent, but if you write nothing, then the examiner is going to give 0 because there's a blank space. So in the exam, never leave a blank space. Always try, always write something. You get part marks for that. So the coordinates of B are this. So what is then the area of this shape? And what do we call this shape here? That is two parallel sides. There's a shape that is like so. Shape that is like so. Okay, and this shape like so has two parallel sides. What do you call this shape, guys? Anyone? It is called a trapezium. It is called a trapezium or a trapezoid. Right, so this is a trapezium. What is the area of a trapezium? The area of a trapezium is half into the sum of parallel sides multiplied by the perpendicular height. So, if this is the case, what are the parallel sides? There are 8, and the length here, so this one is 8, but now here the length from here to there, it's exactly 14. So it's 8 and 14. Okay, those are the parallel sides, and then you multiply by the perpendicular height. The perpendicular height is 6 units. So you're going to say half into the sum of the parallel sides, 8 plus 6, or 8 plus 14, excuse, multiplied by 6, perpendicular height. So we say now we need the area of that shape. So the area of OCBA is actually 1/2 into the summation of the parallel sides, and we multiply by the perpendicular height, like this. So what is this, folks? What are the parallel sides? I've already said they are 8 plus 14. Okay, and then the perpendicular height is only 6 units, the length of OC. If you use a calculator, this becomes 66 square units. 66 square units. If you don't want to say 66 square units, you say 66 units squared. Okay, that is what we get. Next question. Question 2. Prove that M equals P. Okay, M is this and P is that. So M and P are like trigonometric expressions. We need to prove that M equals P. So we need to prove that this trigonometric expression is equal to that trigonometric expression through simplification. And the aim in mathematics is to take the most complex of these. So we're going to take the most complex, and the most complex that has like the most terms is m. So m is 2 the sine squared. 180 degrees minus theta plus the sine 2 theta cosine 2 theta, which is 2 into the 180 minus is actually in the second quadrant, in which the sign is positive. So it becomes the sine squared theta plus sine 2 theta. And we divide everything by cosine 2 theta. And this is exactly the same as what? From the numerator, you can pull out the highest common factor, what we call the highest common factor, the HCF. Right, so it is actually the sign we're pulling out, and we're left with the sign here. Okay, but first, let me write a trivial step and say this is 2 sine squared plus sine 2 theta is 2 sine theta cosine theta, and it is actually divided by cosine 2 theta. Okay, so pull out the highest common factor from the numerator. You have 2 sine theta. You put it out, and it becomes, so you're left with the sine here, and you're left with cosine theta, and you divide by the following. So in the denominator, cosine 2 theta. Okay, for those who are, cosine 2 theta has 2. It's called the double. We call these the double angle formulae. Cosine 2 theta is 3 things, like it is cosine squared theta minus sine squared theta. But also cosine 2 theta is 2 cosine squared theta minus 1. Cosine 2 theta is 1 minus 2 sine squared theta, in which case we need to choose one of these. But the top already has like sine and cosine, so you need to choose something like this one here. That has both the sine and the cosine all at once. So that wherever there's cosine 2 theta, you can put cosine squared theta minus the geometric sine squared of theta. And this is m equals, you have to the sine of theta into the sine of theta plus cosine theta, which is cosine theta minus sine theta. And then you have cosine theta plus sine theta. And what is all this here? If you simplify this, the sine theta plus cosine theta cancels the sine theta plus cosine theta, and it leaves us with 2, the trigonometric sine of theta, which is divided by cosine theta minus sine theta. And these 2 sine theta over cosine theta minus sine theta, I mean, this is equal to P. So it means therefore at this point you have that M is equal to P. So M is equal to P because you have 2 sine theta divided by cosine theta minus sine theta. Anyone, any question? No question. So we have used the double angle formula, but also we used the other double angle formula. There's only one double angle formula for the sine 2 theta. Okay, so you need to take down a couple of points. Sine 2 theta is 2 sine theta cosine theta. Okay, some of these things some people might have not seen yet. So yeah, I know there are things. So you are learning more anyway. So there's no harm in doing extra mathematics here. Okay, right. So we have proven this. What is this? What was the aim? The aim was to prove that M equals P. So we took M, we manipulated, we simplified M until we got something like this, which is 2 sine theta over cosine theta minus 1. And this is P, exactly P. We move on to the next question. Move on to the next question. For what values of theta will P be undefined if theta lies between those? Okay, so we are looking at P. And what is P, guys? P is exactly this here, and P is exactly this. P is exactly, P equals 2 sine theta over cosine theta minus sine theta. Let's write down P. Right, so P is 2 sine theta divided by cosine theta minus sine theta. This is P. And then they're saying for what values of theta will P be undefined? So if P is undefined, obviously P is undefined when the denominator is equal to 0, which means it is when cosine theta minus the geometric sine of theta is 0. So this means that we have cosine theta will be the same as you transpose these to become the sine of theta. How do we solve this? Okay, to solve this one here, you can divide it straight away. Cosine theta is equal to sine theta. We need to solve for theta. So we can divide the left by cosine theta, divide the right by cosine theta, which means 1 is equal to the tangent of theta. So now at this point, we get something we call the reference angle. What is the reference angle? Right, so the reference angle at this point is equal to the arctan of 1. And arctan of 1 is equal to 45 degrees. So in mathematics, we think like this, and we draw the cast diagram here. And we realize that the tan is 1, so if the tangent is 1, a couple of things become extremely important. And what are those things? The things that are important indicate clearly that at this point here, we have that the tan is positive. So all are positive here. The tangent is also positive there. So in other words, we have those angles there. Right, so with that said, but also look at this, where the angle theta is there. So which means therefore here theta is an element of the interval. Okay, is an element of the interval as follows. So which means that here at this point, we have that this is the reference angle 45 degrees. So this one is 45 degrees. But also you can measure the angle from here to here like this, which is minus 135 degrees. And then now, how do we know it's 135? Because this angle is equal to this angle. They are vertically opposite angles. So yeah, this becomes also 45. So that at the end of the day, you can also measure this angle here. What is the size of this angle? This is 180 up to this point because it's a straight angle, and 180 plus 45 gives us 225 degrees. So which is minus 135 degrees. And then it is again, you also have 45 degrees. And then you have also 225 degrees. Those are sort of the angles that you can state there. So for what values of theta will P be undefined? So P will be undefined for these angles here. Okay, so we continue right now until we get more problems and we solve the next questions. Okay, here is the part B. Part B is a very interesting one. They are saying in which quadrant is angle beta. Okay, so now sine beta is positive, but cosine beta is negative. So you need to look, obviously deal with the cast diagram. And then say in which quadrant is sine positive, but cosine negative. But they said just circle the number. So the number that is actually encircled is the number 2. So it is the second quadrant because quadrant 1, quadrant 2, quadrant 3, quadrant 4. In which quadrant is angle beta? Yeah, is the angle beta. So obviously it is in a quadrant in which the sine is positive and the cosine is negative. That is actually the second quadrant. Next question. Without the use of a calculator, determine the value of the tangent of beta. Right, how do we find the tangent of beta without the use of a calculator? Right, so a couple of things are very important. Right, so you need to realize that at this point, what we have is we need to answer this question, and we know that the angle beta is an angle that is in the second quadrant, so that is beta. So you have, okay, which means the sine of beta. So the sine of the angle beta, therefore, is opposite of hypotenuse, which is opposite the square root of 2. The hypotenuse, square root of 11. In view of SOHCAHTOA, so now we have just used opposite over hypotenuse. Opposite of hypotenuse, cosine is adjacent over hypotenuse, and so on. Now, we want to find the tangent, but the tangent uses opposite of adjacent, so we must get the adjacent side, so we must get the x over there. Okay, so which means that we have Pythagoras, which is x squared plus y squared is equal to the radius squared. So we substitute, we are looking for the x squared, and the y is the square root of 2. You square that one. The radius is the square root of 11, you square it. So which means this one is 11 minus 2, then you take plus or minus the square root. So this one here, it's 11 minus 2. And 11 minus 2 is actually a big 9. And the square root of 9, you all agree, is plus or minus 3. But here we put negative 3 because it's on the negative side. Okay. What is the tangent of theta? So at this point, we can realize that the tangent of beta, not theta, but beta, right, it is the opposite over the adjacent. So we have the opposite, which is the square root of 2. The adjacent is minus 3. Okay, we have that. We have that. And that is the answer. But to find the tangent of beta, it's the square root of 2 over minus 3. Next question. Right, at this point, we need to perform a proof. Right, you need to prove that this is equal to that. So you need to prove that at this point, this is actually the sine of alpha. So you take the left-hand side, let. So there are two ways to prove this one. Either you prove that you take this one and break it down, simplify it to sine theta, sine alpha, or you have sine alpha and you make it more complicated into this. So it's not easy to make things complicated, but it's easier to simplify. That is why in mathematics, the questions normally are you need to simplify. Normally, there's no question that comes and says complicate. Okay, I mean, it would be ideal to complicate things. But yeah, the mathematicians realize that simplifying is more natural. Right, you're given something big and you need to break it down. So we take the left. Alpha minus 30 degrees minus the cosine of alpha plus 30 degrees. Okay, what is this here? So you break it down, these. What is the formula? There are formulas we learn. In mathematics, the cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. And the cosine of alpha plus beta. It is cosine alpha, cosine beta. We have the plus, which is minus sine alpha, sine beta. So if it's minus, it becomes plus. If it's plus, it becomes minus. What do we call these formulae? We call them compound. We call them compound angle formulae. So now you have these. So now you need to expand these here. So this is cosine alpha. Cosine beta is 30 degrees. Okay, it's minus, then it becomes a plus. The sine of alpha, the sine of beta, 30 degrees. Minus. So you have this, which is cosine alpha, cosine beta, minus sine alpha, sine beta. So what are we getting here? So we need to distribute, just open the brackets here. So this is cosine alpha, cosine 30 degrees, plus the sine of alpha, the sine of 30 degrees, minus cosine alpha, cosine beta. Okay, minus times minus becomes a plus. The trigonometric sine of alpha, the trigonometric sine of beta. So you take these. Okay, here I just called alpha and beta. Please note that obviously it's alpha and 30. So this one is going to be like 30 degrees here, and you will throw this one here. And this one here, obviously, yeah, it's alpha, and the second one is just going to become 30 degrees here. So that this one on top of the beta, you have 30 degrees and not the beta. And here you have 30 degrees and not the beta. So that means I need to write down a very obvious step, which is cosine 30 degrees here, plus the trigonometric sine of alpha, the trigonometric sine of 30 degrees, minus cosine alpha, cosine 30 degrees, plus the sine of alpha, the sine of 30 degrees. So what is the left-hand side? So these two guys cancel out, and then you have sine alpha sine 30, which is 2 the sine of alpha, the sine of 30 degrees. So the left-hand side is the same as the following. So you have to the trigonometric sine of alpha. What is sine 30? Okay, so now you have a special triangle like this that has this upper angle being 30 degrees and this one being 60 degrees. And this one here is 2 the square root of 3, 1. So what is sine? Okay, we said SOHCAHTOA. SOHCAHTOA. And therefore, you are dealing with a sine of 30 degrees. And it is actually obviously the opposite over the hypotenuse. Opposite 30 is 1. The hypotenuse is 2. And this one is called a spatial triangle. Called a spatial triangle. Right, so that we have exactly this, the left. You multiply this, which is sine alpha. And this one is the right. And this is the answer. Okay. So we have this. Okay. So this is what we get. Next question. So we've proven that this is equal to sine alpha. Next question. Okay, hence, determine the general solution to the equation, this one. Hence, determine the general solution to the equation, this one. Right, so we know, recall that we started with cosine of alpha minus 30 degrees minus the cosine of alpha plus 30 degrees. And we're able to see that this one here is actually the sine of alpha. So this here is actually the sine of alpha, this. So with that said, it means that in the place of this long thing, two-term expression, we put the sine alpha, sine squared alpha. Right. With that said, then we continue as follows. And we can manipulate these and say we have the sine of alpha minus 2 sine squared alpha, which is 0. We have sine alpha into 1 minus 2 sine alpha, which is 0. Which means sine alpha is 0 or sine alpha is 1 over 2. So at this point, what is this? Okay. So alpha is going to become what? So there is some reference angle, which is arc sine 0, and that is 0 degrees. If it's 0 degrees, then alpha is actually what? If it's 0, then here the answer is going to be the reference angle plus the period of the sine function, which is 360 degrees times k, where k is an element of z. Simultaneously, you can have the following. So you have the reference angle being exactly 0 degrees. And so, but also we understand that the associated with the reference angle is also 180 degrees, where the sine is 0. So this is also 180 degrees plus 360 degrees times k, because the period of the sine function is 100 and is 360 degrees. So this one here, we continue, but also we look for the reference angle here. So the reference angle becomes arc sine of 1/2. What is arc sine of 1/2? It is actually 30 degrees. So which means alpha is 30 degrees plus the period of the trigonometric sine function, which is always 360. 360 times k, where k is an element of z. So now we only have another one. Okay, so it is the sign is positive in view of the cast rule. The sign is positive in each quadrant. It is positive in the first where all are positive, but it's also positive in the second. So 30 degrees is an angle that sits here. Okay, we agree. But there's also another angle that sits exactly here. And this angle is going to become 180 because this is 180. So it's 180 degrees minus the acute angle. So that angle is going to be 150 degrees in size. So this is 150 degrees, 360 degrees times k, where k is in z. So you have this. We have this. We have this. Okay. Next question. So now here we're determining the general solution. So the general solution must be in terms of k. The general solution must be in terms of k, the integers. The integers. Okay, next question. Okay, we look at more questions on geometry, more analytical geometry. In the diagram below, circle P touches the x-axis and the y-axis. Let's look at P. Yes, circle P, it touches the x-axis, but it also touches the y-axis. So much so that you can imagine that these two are tangents from the same point. The y-axis is a tangent, and also the x-axis is a tangent to the circle P. Circle P touches circle Q at one point. So circle P touches circle Q at one point. So these two circles sort of touch externally. They touch externally. Right. So circle Q touches circle R at one point. Second Q touches, here's Q, touches second R at one point. They also touch externally. Right, so second P has a radius of 5 units. So this second P has a radius of 5 units, meaning this is 5 units and also this is 5 units. Right, PQ is parallel to the x-axis. So we have that PQ is parallel to the x-axis. Right, so, and also, and RQ is parallel to the y-axis. So you have that. So PQ, this one is parallel to the x-axis, and there's also RQ, which is parallel to the y-axis. Okay, PR cuts the circles with centers. Okay, so there's PR. Here is PR. Cuts the circles with centers P and R at A and B respectively. So this PR cuts at A and B respectively. If PQ is 9, okay, so they've given PQ is 9, determine the equation of circle Q. Right, so obviously we know that PQ is 9, so the distance from here to there is 9. So PQ is 9. So now, what is the radius? Uh-huh. So the radius. Radius of circle Q. What is the radius of circle Q? Okay, if this whole distance now, the whole length is 9, but this is 5, so it's going to be exactly 9 minus 5, which is 4 units. If on diagram, then they get the, okay, never mind that. Okay, so we have that. Now XQ of the circle with of the center of the circle is what? Right, so at this point, we are interested in XQ, but also in YQ. What is XQ here? Right, XQ, because we've already seen that this one is 4 units. So what is XQ? XQ is going to be exactly, we can write here, XQ. XQ is going to be precisely 9 plus 5. Right, because we already know that the distance from here to there is 5. So we have 9 plus 5, which is 14. YQ. So YQ is also clearly the radius here, the distance from here to there. So you can get YQ here. So it's also 5 units. All right. So YQ is 5. That gives us the equation. The formula we're going to use is that x minus p squared plus y minus q squared is the radius squared, which means x minus xq, which is 5, plus rather x minus 14. We use 14. So x minus 14. So let's remove this. So we have exactly, if I'm to remove these totally, and have x minus, okay. Now x is 14 here. And then you square these. What is y at q? Right, so we can see that y is 5. You square these, and that becomes, therefore, the square of the radius. The radius is 4. For this sacral center q, the radius is 4. So you have 4 squared. All right, so this answer can also be written as x minus 14. You square that plus y minus 5. You square that, and this is 16, and that is the answer. Okay, because we determine the equation of sacral q. And sacral q is this one here. It does not even touch the x-axis. It's just above the x-axis, but it touches the other sacrals at 1 point per second. Okay, we continue. We continue. Find the length of R of QR. If the equation of sacral R is this, find the length of QR. Let's see QR. Where is QR? Find the length of QR. This one? Okay. If the circle of center R is this one. Okay, the circle of center R now, we just need to write it properly, this circle here. We need to write it properly. So to write it properly, we must be able to find the coordinates of the center. So it's x minus p squared, and then we have y squared minus 22y. We need to complete the square. So we're going to take half the coefficient of y, which is minus 22, and then we square it. Subtract the same thing. Okay, and this is minus 117. So you have that. So this is plus y minus. Okay, half of 22 is 11. You square it. Transpose everything to the other side, which is minus 117. If you square 11, okay, you square the 11 here. So this is going to be exactly, there's a minus there. So it's going to become plus 121. Okay. So this is minus that squared. Y minus 11 squared. And this is exactly the same as the 121 gives us 4. So obviously that gives us the equation of the circle center R. Okay, if you have the equation of circle center R, find the length of line QR. The length of line QR. Let's see. The length of line QR. What is then the length here? Right, so obviously a couple of things you need to consider at this point. What are the coordinates of Q? XQ. XQ is 14 and YQ is 5. So the coordinates here are 14 together with 5. So you need to go up a little bit, but this one we've seen that is x minus p squared plus y minus 11 squared is equal to what? It's equal to 4. Okay, we have this. Obviously, this has to do with the coordinates here at the point R. So what this gives us is that now we need to find the coordinates. What are the coordinates of R? They are P together with 11. So if you want to find RQ, then it is vertical. So you use the Y. So it must be actually 11 minus 5. 11 minus 5, so that we are able to find the length of RQ. So RQ is going to be 11 minus 5. Right, so find the length of line RQ is equal to 11 minus, what is 11 minus 5? 6 units. Okay, 11 minus 5 is 6 units. Okay, okay, next. Determine the length of AB, correct to 2 decimal digits. Correct to 2 decimal digits, the length of AB. The length of AB correct to 2 decimal digits. Right, how do we therefore find the length of AB correct to 2 decimal digits? So, okay, hey, here's Waruna. So I want to find the length of AB. I want to find this one.
Are there many people? No, thanks.
Okay. So I want to find the length of AB. How do we find the length of AB? Well, to find the length of AB, we already know some of these. Like, you already know the length here. What is the length here? If you want to find the length of AB, what is PR? What are the coordinates of P? Right, so the coordinates of P can be obtained because we already know the circle center P. Well, we know the radius is actually 5 units, and therefore we have some knowledge about this. What are the coordinates here? So it means therefore at this point from here to here is 5, and also it is 5 elsewhere as well. Okay, so that is for circle P, and therefore you can be able to find the coordinates there. So these are 5 and 5. Right, then you have the coordinates at this point. Okay, look at this. Now, x is 14 here, which means that now this is parallel to the y-axis. So it means x is 14. This is a vertical line. X is the same across. So this is also 14, 11. Okay, with that said, then we can be able to find the length of PR. We are going to look at, and then now we just need to subtract. The radius is 5 here. This one is having this, which 4 is 2 squared, and 2 is the radius. So 2 becomes the radius. So here, this one is radius 5, this is radius 2. So if you find the whole length of PR, you can just say from PR, if you remove this little bit, you remove that little bit, you get the length that's required. So let's find the length of PR. So P has coordinates 5 and 5, and R has coordinates 14 and 11. That's what we're going to write down. Right, so P has coordinates 5 and 5, and obviously we have that R has the coordinates 14, and has the coordinates 14 and 11, R. 14 and 11. So we have these 14 and 11. Right. So what is, this is P and that is R. So what is PR? Yes, please. Oh, is it? All right. Are you having it now? Okay, I'm coming. All right, we're finding the length of PR, guys. Okay, okay, okay. I can hear you, Ayanda. You say your phone battery is low. All right. Okay, thanks for listening. I can hear you, Ayanda, you're saying your phone battery is low. I can hear you, Ayanda, you're saying your phone battery is low. Okay, we want, okay, so let's find PR. So this one is x1, y1, and this one is x2, y2. So the distance formula says x2 minus x1 squared plus y2 minus y1 squared. So which means you have PR. What is x2? It is 14 minus 5 squared plus the y2, it's 11 minus 5. It's 11 minus 5, and then you square this. Okay, so we continue. We continue. Okay, so, right, so at this point, what does this give us? So if you use a calculator, you realize that this is going to give us the square root of 117. So we have a situation like this. Here it's P, and there is R, and here is A, and there is B. What is PR? PR is everything. Square root of 117. What is PA? The radius of the other circle down here is 5. The radius of the other circle is 2. So, which means that with AB, so AB is this one, which is PR, which is exactly PR. All right, so which is PR minus, so from PR you subtract PA, but you also subtract BR. Okay, from the whole PR, you subtract these and you subtract that, then you can get AB. So which means that AB is PR, which is, what is the length of PR? It's the square root of 117 units. What is PA? The radius here in the diagram has 5 units, and this one is 2 units. All right. So it means at this point, our AB is the square root of 117 minus 7 units. All right. Like that, if you use a computer, it is actually 3,82 units. Okay. So yeah, we are done. Next question. Next question. We continue. We continue. We continue. Next question. The next question is this one here. So this one is about circular geometry. Use the diagram below to prove the theorem that states that the opposite angles of a cyclic quadrilateral are supplementary. Here's the diagram. Right, so we can perform some construction here, like so. 1, 2. So now you need to indicate that you need to draw. So you perform a construction. You need to draw AO and OC. We are required to prove that angle B plus D. Angle B plus D. So we're required to prove that angle B plus angle D is 180 degrees. So we're required to prove that angle B plus angle D is 180 degrees. Okay, let's write down the proof. Here is the proof. So how do we write the proof? So we're gonna first say, first things first, angle O2 is equal to twice B. Angle O2 is twice angle B. If you look at the shape like this, you can see that angle O2 is twice angle B, angle at center is twice angle at circumference. So angle O2 is twice angle B. Angle at center is equal to 2 times angle at circumference. But also you have that angle O1. Angle O1 is twice D. Angle O1 is twice D. Angle O1 is twice D. Angle at center is 2 times angle at circumference. So what is the meaning of this now? Right, so what we can see at this point is that angle O1, right, angle O1 plus angle O2 is actually equal to 360 degrees. Okay, so we continue. So, which means that we have here O1 is twice D, O2 is twice B, 360 degrees. Which means B plus D, you divide through by 2 and you get 180 degrees. So obviously we have been able to prove that angle B plus angle D is 100 and what? And 80 degrees. Is 180 degrees. Okay. So we proceed now. We proceed now. So which means angle B plus angle D is 180 degrees. And we've proven that. Because the question obviously was that use the diagram below to prove the theorem that states that the opposite angles of a cyclic quadrilateral are actually supplementary. The opposite angles of a cyclic quadrilateral are supplementary. And we decided to perform a construction and prove that the other angles, B plus D, sum to 180 degrees. There it is, and done. And we're done. So we continue. We continue. Okay, in the diagram below, O is the center of the circle. So you have O is the center of the circle. A, B, and C lie on the circumference of the circle. So you have that A, B, and C are on the circumference of the circle. And you have that line DAE is a tangent to the circle at A. So at point A, so you have DAE is a tangent to the circle at point A. You have that A4 is 62 degrees. So you have that angle A4 is 62 degrees. Let's check this one. A4 is actually 62 degrees. So yeah, here is A4. It is 62 degrees. And you have that angle A2 is 25 degrees. This one here is 25 degrees, like this. Okay. And then now what does the examiner want? Calculate the size of the angle C1. They just want the size of the angle C1. What is the size of the angle C1? So, first things first, you need to look at this question and realize that angle ABC is 62 degrees because of the ten-chord theorem. So if you have a circle like this and there's a tangent here and this one here and this one there and this one here, so the angle that sits here is equal to the angle that sits here, and this is called the ten-chord. It's called the ten-chord theorem. So which means that angle ABC ABC is equal to 62 degrees, which is the ten-chord. So which means, therefore, this one here is 62 degrees. Okay, if this one is 62 degrees, then we have angle AOC. AOC, angle at center. Angle at center. So we have that angle AOC, right, is equal to 2 times ABC, which is 2 times ABC 62, 124 degrees. Angle at center. Two times angle at circle. Angle at circumference. So which means therefore that we have that this angle here is 124 degrees. AOC is 124 degrees, this one. All right. But obviously this equals this because these are radii. These are radii. Each one of them is a radius, and therefore we can be able to perform further simplification because we can see clearly that angle at this point, angle C1, angle C2 to start with. Angle C2 must be equal to angle A3. So angle C2 is equal to angle A3. Angle C2 is equal to angle A3, which is equal to 28 degrees. 28 degrees. Okay, because these angles here are angles in a triangle, so they must add up to 180. So it's this plus 56. 50 plus 20 is 70. 56. So now 56, you divide 56 by 2 because these are equal. So you get actually 28 degrees. So which means C2 is equal to A3, which is equal to 28 degrees. So We continue. Now, after we got that C2 is equal to 28 degrees, we can easily get, so this one is also 28 degrees, and this one is also 28 degrees. Then now we need to get just this little bit here, which means we need to sum all the angles in a triangle. So these plus everything here must add up to 180 degrees. So we can say C1 is equal to 180 degrees minus this with this with this. So C1, angle C1 is 180 degrees minus this 62 we saw. There's 62 degrees, and then there's 25 and 28. So minus 25 minus 28 minus 28 also. So this is 37 degrees. Angles in triangle. Angles in a triangle. C1 is 37 degrees, angles in a triangle. So what is angle C1? In the diagram here, angle C1 is 37 degrees. Okay. Next question. What single statement can be used? What single statement can be deduced from both of the following statements? Okay. What can we deduce from the following statements? That at this point, angle M plus angle D is angle M plus N is D plus and M plus Q is D. What do we deduce at this point? Well, if M plus N is D, M plus Q is D, we can deduce that angle N must be equal to angle Q. Right. Alternatively, you can say that you can deduce that angle M plus, or rather M plus N, not really angles, but M plus N is M plus Q. So, which means N equals Q, or you can say M plus N equals M plus Q. All right. In the diagram below, A, B, C, D lie on the circumference of the circle. Let's check. A, B, C, D lie on the circumference of the circle. Prove that B is equal to A1 plus C2. Prove that B is equal to A1 plus C2. First things first. Let's prove this one with ease. How do we start? Okay, first things first, we can see that angle D1 is equals to angle D. Angle D1 is B. Angle D1 is B, the exterior angle of cyclic quad. So we can see that first things first, so we write here that angle D1 is equals to angle B, exterior angle of a cyclic quad. Okay, the exterior angle of a cyclic quad, yeah. If you just say exterior angle of a cyclic quad, we know it is equal to the interior opposite angle. So angle D1 is equal to angle B. But also we have that D1 plus A1, or rather D1 is equal to A1 plus C2, the exterior angle of a triangle. So we have that angle D1 is actually equal to what? Angle D1 is actually angle A1 plus C2. Angle D1 is A1 plus C2. Okay, we did this in grade 10. And we're doing this in grade 10. And we're looking at these. And we're like, an angle here is the sum of those angles that are sitting there. All right, so now this is the exterior angle of triangles. So which means angle D1 is A1 plus C2. Which means that at this point, you have the exterior. angle of triangle equals the sum of the interior opposite angles. So, okay, these two guys, they're both B1. And the conclusion, therefore, is that angle B is equal to A1 plus C2. Okay, so we have angle B is equal to A1 plus C2. This is what we got. So this is what we're supposed to show. Angle B is equal to A1 plus C2, and we've shown that. And we've shown exactly that. From the diagram here, this question, we have shown exactly that. We have shown exactly that. Okay, next question. Okay, now we're looking at some nice things. And these nice things we're looking at are basically the geometric graphs. Let's check the graphs a little bit and see what we can do with the graphs. Write a graph of the f of x function, which is 3 sine x plus 1, with x lying between 0 degrees and 360 is drawn below. Line AB is parallel to the x-axis. So AB is parallel to the x-axis. A is a point on the y-axis. Yeah, there it is. Write down the coordinates of point B. We need to write down the coordinates of point B. So now the coordinates of point B is a point where the sign again becomes 0 degrees. It becomes rather 0 between 0. Okay, obviously this is drawn between 0 and 360, so this one is 0 degrees, and this is 360. And this is 180. It's in the middle, sort of. Right, so the coordinates of the point B will be nothing other than B will have coordinates x equal to what? Okay, so yeah, write down the coordinates of the point B. So right, point B is a point that sits here at a point where, okay, remember this here is the origin. This. Okay, so yeah. So this is actually 0 degrees, and yeah, it is 0 degrees there as well. So 360 degrees here on the x-axis and there. But remember, the graph is moved up. This graph is translated, so it's going to move up by 1 unit. So which means B will have coordinates what? It's going up by 1 unit, so B will have the coordinates x equals 360 degrees, and y is clearly a 1. So which means that at this point, your y is equal to 3 sine x plus 1, which is 3 the sine of x, which is, you can be a substitute here. X is 360 degrees. So you put 360 degrees plus 1, which is equal to 1. So 360 and 1. Calculate the values for x where this is the case. Calculate the values for x where this is the case. So where you have that y is negative 1. So that would be at a point where f of x is minus 1. What is f of x? F of x is 3 sine x plus 1. So f of x, you can see it's actually 3 sine x plus 1, which is minus 1. And this is 3 sine x minus 2. which means the sine of x is minus 2/3. What is the reference angle? Right, so you take the positive, so the reference angle is going to be arc sine of 2/3. Arc sine of 2/3 is 41, 81 degrees. So, okay, we're looking for where the sign is negative, so you have the cast rule here. We agree that at this point, the sign is negative here and it's also negative there. So it is negative in those two quadrants. So in other words, so the x is the same as 180 degrees plus 41,81 degrees. And this is exactly 21,81 degrees. Which means that here you have x equals 100. Now this one is going to be 360 degrees minus this one here. 360 degrees minus 41,81 degrees. And this is 318. 318,19 degrees. So that is 318,19 degrees for, yeah, that little part there. Obviously, we're asking calculate the values of x for which this is minus 1. So the values of x are two of them. So we can say that x is an element of the set where x is 221,81 degrees and 318,19 degrees. Okay, so we continue. Next question. If g of x is equal to k, if g of x equals k, right, so we continue. So yeah, if g of x is equal to k and k is a constant term, then for what value of values of k will f be g have no real solutions if x is in that interval? So if you look at C, if g of x is k and k is a constant term, so then for what values of k will f be g have no real solution? Let's look at this. What is g of x? What is g of x at this point? Right. Okay. Well, g is some function that is a constant. So then for what values of k will f be also a constant, such that you have no real solutions. So obviously we agree that if you look at the fact that the function f of x um we continue. We continue. All right. We continue. So we're looking at the point where ultimately f of x is going to become a constant equal to some constant function such that we have no real solution. So that would mean, obviously, if you look at the graph, right, something like that here. Okay, so if you're halfway, what is the maximum that this function can reach when at 90 degrees? Okay, want to find the maximum? So at 90 degrees, like it's going to be 3, the sine of 90 degrees plus 1. Sine 90 is what? Is 1 plus 1, and this is 4. So this is going to be at 4. And potentially also at minus 270 degrees, it's going to become minus 4. All right. So that in the end, when do we have no real solutions? When we can draw a line that does not like touch the function f. So, but that would have to happen if we draw a line that passes through a number that is bigger than 4, because at 4 exactly, it's going to have one in a point of intersection. At minus 4 exactly, a horizontal line is going to touch once. But if you draw at a number, so it's when the number is bigger than 4, or when the number itself is actually, so you're going up to high there. Okay, so yeah. Okay, note that at this point here, it's gonna become what? Okay, so you need to look and think very, very carefully. So it's when k is bigger than 4. Let's start there. So that will be when k is bigger than 4. Or at what point then do we have another situation? Okay, so it means therefore, if you come to the bottom here, right, so at the bottom here, then it's going to be a different story. Right, so it's going to be a different story. Right, so at the bottom it's going to be a different story. So you can have a case like that. Well, what about if k is 1? What about if k is 1? We continue. Okay, what about if k is 1? Or k is smaller than 1, like 1/2? So which means that if k is smaller than 1, right, so we are looking at the 3, f is 3 sine x plus 1. So if you allow this one to be a number bigger than 4, then you're going to have exactly a problem. Okay, I mean, an example would be that if you allow it to be 5. So what is sine x? It's going to be 4 over 3 bigger than 1. So this one is invalid because the sine function cannot be bigger than 1. Okay, the sine function is a bounded function minus 1 and 1. So um, we'll continue. If it's smaller than 1, like 0, 0.5, yeah, you put 0, 0.5 here, like 3 sine x plus 1 is 0, 0.5. Let's see what we get. So which means the sine of x is minus 0, 0.5. Let's see what we are getting there if that is the case. All right, so if you have less than 1, so you would have the sine of x being minus 1 out of 6. Okay, so okay, we're investigating here. So you can see that the case where k is bigger than 4, then we have a problem because it's bigger than 1, 4 over 3. But also, in other words, that is the case when we are above here, because obviously at 90 degrees, it's going to be sine 90 plus 1, which is 4, which means it's going to reach up to 4 just above the x-axis. Right, so, but moreover, when you come to the bottom here, what happens? It's either like at 270 degrees, let's see. So if you do 3, the sine of 270 degrees plus 1, which is 3 into minus 1 plus 1, which is minus 3, excuse me, minus 3 plus 1, which is minus 2. Right, so in other words, obviously at minus 270, it's going to be approximately at minus 2 there, at 270. Okay, because 270 is allowed, it's between 0 and 360. So, which means that it's going to be like at minus 2. Okay, if it's going to be like at minus 2 at 270, what more are we going to have? So now we continue. We continue. We continue. So what do we then get at this point? Yeah, I was saying approximately minus 2 there. Just at minus 2, because at 270, then you put it here, it's going to be like minus 2. So when would you have that, for example? So which means therefore, if you allow if this is going to intersect at minus 2, but now you can take something below that. So take a value that is below that. So anything less than minus 2, you try, investigate this question. For k, you try k less than minus 2. So that's going to be like, if you take this function here, it's going to be 3 sine x plus 1 is, maybe you try minus 3 for argument's sake. Okay. So what do we have? You have 3 sine x, which is minus 4. So obviously at this point, the correct one would be this, or when k is less than minus 2. So these are sort of the two. When k is bigger than 4 or k is less than minus 2, this will actually be the correct answers to this question for the 2 marks. Okay, so just think about this. This video is being recorded, so you'll have a perfect chance to sort of begin to watch these things and make the most of this. Okay, so we continue. We continue. We continue. We continue. Right, we continue. Okay, continuing now, we have more things. What more things do we have? What more things do we have here? Right. So, we continue. Right. Right. We continue. Okay. Right. We continue. Okay, think about these, yeah, but that's the answer. Right. Right. Okay. Right. So, um, we continue. Okay. Okay, we continue. I'm looking at the next thing. Okay, so this one I jumped. These questions I jumped. These questions I jumped. This question I jumped. This question I jumped. Okay, let's look at question 8. Let's look at question 8. Right in the diagram below, circle center T touches the x-axis at R. Center T touches the x-axis at what? At R. Okay, right. AO is a tangent to the circle at P. Here it is a tangent. OT is 5 units. So you have OT is 5. So let's check that one. And TP is 3. TP is 3. Determine the coordinates of T. What are the coordinates of T? Okay. Right. Obviously, if you look at the fact that there's a radius and a tangent, so a radius is always perpendicular to a tangent at the point of contact. So yeah. So this is 5 and this must be 4. This is called a 3, 4, 5 triangle. TR. This one. Okay, so which means that TR is 5. Is there other 3? Like the radius? Moreover, we have that TP is perpendicular to OP. Okay, you have that TP is perpendicular to OP. Or you have that OR. OR is perpendicular to TR. Or we can say OR is perpendicular to RT. So what is OP squared? So OP squared is equal to, which is this one? By Pythagoras, OP squared is equal to, this is the hypotenuse, which is 5 squared minus 3 squared. And this is 25 minus 9, and this is 16. Okay, so which means that OP squared is 16, which means OP is 4 units. OP and OR. Okay, OP and OR are equal because they're tangents drawn from the same point. So OR is also equal to 4 units. Tangents drawn, all right, these are tangents drawn from the same point. Tangents drawn from same point. Okay. Okay, it means OR is 4, but also this one is 4. What is XT? XT is also 4. So here, it means the X is 4 here, the coordinates here are 4 and 0. So this is 4, then the top one is 3. Which means T has coordinates 4, 3. So T will have coordinates 4, 3. Okay, so T will have coordinates 4, 3. So right, because we need the coordinates of T. So yeah, the coordinates of T are 4 and 3. Like that. What is the next question? Determine TOR. Let's check. Angle TOR. What is angle TOR? So obviously we have these 3, 4, 5. So the angle TOR is the tangent of the angle TOR is the opposite of the adjacent. So the tangent of TOR is opposite of adjacent, which is 3 over 4. The tangent of TOR is opposite over adjacent. Which is arc 10 of 3/4. If you use a calculator, it becomes 36,87 degrees. So we're interested in finding the actual angle TOR, which is because we have this triangle, 3, 4, 5, and this is the angle ORT. Okay. ORT. So now determine YP, the Y coordinate of P. Determine YP, the Y coordinate of P. Determine YP, the Y coordinate of P. How do you find the Y coordinate of P? The Y coordinate of P. Right, so we can easily find the Y coordinate of P because this shape here is a kite. This equals this and this equals this. So it's called a kite. If it's a kite, then you have this here. Right. My goodness me. So we continue. We continue. So if this is a kite, we are interested in finding the coordinates of the point P. What are the coordinates of the point P? So we're just going to use lengths here. We're just going to use lengths. Right. So, but if we use lengths, how do we find the coordinates of the point P? We analyze that together. This is 4 and 4. Then what are the coordinates over there? We continue. Right. So we can be able to find actually the angle POR. What is the angle POR? Okay, because it's a kite, this angle here is equal to that angle there. So if you find angle POR, it becomes double TOR. So POR, it's twice this. So which means POR, it's twice TOR, which is twice 36,87 degrees, which is 73,74. Properties of a kite. Properties of kite. OPTR. Okay, we found the angle 36,87 for TOR. So now we just multiply it by 2 so that it becomes this. Right, so now we can be able to find the sine of POR. Let's check the sine of POR. The sine of the angle POR. What is the sine of the angle POR? The sine of the angle POR is right. So if you look at the angle POR, and we attempt to find the sine of that angle there. And then we can be in a position to find the y at P. All right. Okay, so we can be able to see that one. So in other words, you can drop this one here like this. Right, then you're dealing with this. So that the sine of POR, right, the sine of the POR, this one here is the opposite YP over the hypotenuse. All right. We continue. So we realized that we can find the sine of POR, which is opposite YP over hypotenuse, which means YP is for the sine of that. Okay, so this one is, you can put straight away here. Still, this is the sine of POR, which is 73,74 degrees. And this is approximately 3,84 units. 3,84 units. Right. Next question. So we're supposed to find y at P. So y at P is exactly 3,84 units. Continue. In the diagram below, we have C and A are points on the x-axis. C and what? And A are points on the x and y axis respectively. B and A are points on the x and y axis respectively. OB is perpendicular to AC. OB is perpendicular to AC. OB has a length of 20. Has a length of 20, but BC has a length of the square root of 80. It's BC square root of 80. Determine the length of OC. OC squared. Right, so OC squared is like Pythagoras. This is the hypotenuse. So OC squared is going to be the square of this one, like if you use r squared is x squared plus y squared, and this is Pythag. So which means OC squared is square root of 8 is square root of 20. Which is 80 plus 20. 80 plus 20 is what? Is 100. So which means that OC is 100 square root square root. Which means OC is 10 units. OC is 10 units. Okay, I wanted to just find the length of the OC here. So OC is clearly 10 units. Right, there's another question that says, calculate the gradient of the line AC. The gradient of the line AC. AC, what is the gradient of that line there? Right, to find the gradient of the line, AC. Okay, you can use the tangent of BCO. The tangent of BCO. Okay. All right, so the tangent of BCO is like, this is a 90-degree angle. The tangent of BCO is going to become, yeah, the tangent of BCO is going to become the opposite over the adjacent. So the tangent of BCO, this angle, is going to be the opposite angle over the adjacent. This one is the hypotenuse because it's opposite 90. So the tangent of BCO is square root of 20 over square root of 80. Okay, you need to think fast. So it is the square root of 20, the opposite over square root of 80, the hypotenuse. Right, so use a calculator. So that BCO is going to be arctan of the square root of 20 divided by the square root of 80. And this is 26.57 degrees. So then what is the gradient of that? So ideally, we're interested, therefore, to find the gradient, you must find the angle of inclination. Let's find the angle of inclination, which is this one here. So we must say 180 degrees minus that. So which means at this point, BCX BCX is 180 degrees minus 26.57. So we continue. We continue. We continue. Okay, so what did we then achieve out of that? What do we then achieve out of that? Okay, I'm trying to use my calculator to actually get the answer. Which is 180 minus 26 minus 180 minus 26,57, which is 153,43 degrees. Okay, so yeah, that's PCX, which means the gradient of AC is the tangent of 153,43 degrees. So what is the answer to this? What is the answer to this? So this is exactly the same as, okay, so we're gonna take the tangent. Right, so if you take the tangent of 153.43, so this is minus 0.5. So one the gradient, and that is the gradient. Okay, there are many other ways to do this. In which case, this is approximately minus 1/2, or just 1/2, minus 1/2. Okay, calculate the coordinates of B, of point B. Where is point B? Find the coordinates of point B. What are the coordinates of this point? Right, to find the coordinates of this point, we need to perform some construction here. This is going to be like XB, and this is going to be YB. So if this is the case, we need to find the coordinates of the point B. Right, so we already know the gradient of OB. The gradient of OB, because they're perpendicular, the gradient of OB times the gradient of AC is -1. Right. And if that is the case, alternatively, you already know the angle of inclination here. What is the angle here? This one. Okay, we found that angle to be BCO to be 26,57, BCO. Right, BCO is 26,57. So you just need to get this one, 180 minus 90 minus 26,57. One 180 minus 90 minus 26.57. 63,43. Okay, so which means the coordinates of B right? So if you have this triangle, now you have 63,43. So you have this 63,43 degrees. Okay, so yeah, this is square root of 20. And then this is YB XB. Right, let's take this diagram and take it down to the question. To find the coordinates of B, we can realize that we have something like this. Square root of 20, B here. we have YB, we have XB. 63,43. So which means in the end, you have this one is opposite of hypotenuse, which is like the sine of 63,43 degrees is the opposite over the hypotenuse. YB is the square root of 20, the sine of 63,43. But also you have the cosine of 63,43, which is the adjacent over hypotenuse, which is XB equals the square root of 20 sine, cosine that. Okay. We are finishing. So which means at this point, we're going to take the square root of 20. Right, so we have the square root of 20, the sine of that. Right, so we have the square root of 20 times the sine of 63.43. Okay, so this is just about 3.99982. And this one of the cosine. This one of the cosine is 2.00034. So we want to find the coordinates of B. So in other words, the coordinates of B can be seen as this is approximately 4 and this is approximately 2. So the coordinates of there are 2 and 4. Those are the coordinates of B. The coordinates of B that sits like there are like 2 and 4. Just watch what we did there and make sure you understand that. Next question. Right, prove that triangle ABO is actually similar to triangle OBC and hence deduce this. Let's deduce that. Prove that triangle ABO is similar to OBC. Let's check this. ABO, OBC. ABO, 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 OBC. ABO, OBC. ABO triangle, this one. OBC. Prove that. Obviously, you can see that there's an angle of 90, so B equals B there. Right, so you can see that this angle is 90 in this triangle, and this angle is also 90. So that if you take like COB to be theta, COB to be like theta, then the other angle is going to be 90 degrees minus theta. So this is also going to be 90 degrees minus theta. So this is going to become theta. Okay, with that said, we take this diagram, we write. So which means like we saw, we have, if we let angle COB to be theta, angle COB to be theta. Okay. COB to be theta. We have AOC then B. See that? AOC then B. I want to just draw a diagram there a little bit. AOC then B. Okay. COB theta. And then, you know, this one is 90 degrees, so that this one is 90 degrees minus theta. And then this is 90 and this is 90. So this is also 90 degrees minus theta. This is going to become theta. So if you let COB be theta, then you have that angle AOB. AOB is 90 degrees minus theta. Okay, and then also the observation is that angle OAB is going to be 90 degrees minus. So OAB is going to be 90 degrees minus 90 degrees minus theta. Theta. So OAB is 90 degrees minus that. So this becomes theta. It's like 90 degrees minus this. So that it is theta. So anyway, when you add everything here, must be 180 degrees. So it's 90 plus 90 is 180, and theta minus theta becomes a 0. No matter what, yeah, you can find your way to reason that out. And therefore, the observation is that angle OAB is COB. Angle OAB is COB. Angle OAB is COB. Yeah. And these angles are theta. OAB is COB equals theta. Right. So we have therefore that the triangle ABO is actually very much similar to triangle OBC. Angle. And if that is the case, then you take the first two. So you can take AB over OB. BO over BC. OC. So you take the first and the last, the first and the last. So you have BO over BC, which is AB over OB, which is, you can take now AB over OB, which is BO over BC. What is the meaning of this? You can cross multiply these so that AB is equal to OB times OB is OB squared divided by BC. And to prove that this is the case. Right. Right, this is very much enough for today. So I must thank you guys for joining us. I'm gonna post this video in the next couple of minutes. but also the couple of things you need to obviously focus on. I'm gonna return again back on air later on. Let me check the time for those who want to join in. I'm gonna return again at 8:30. Let me see. Okay, I might. Okay, my load shedding. There's load shedding. All right. Load shedding is gonna be the issue. I wanted to return again at 8:30. So I'm gonna be say like now 5 to 7, and then okay. I'm gonna return back again at 10:30. My power is gonna come back at 10:30. So I can return at 10:30 for anyone. So same link at 10:30. I'll be looking at other problems and also looking at paper 2 in detail, more similarity and proportionality and Euclidean geometry. Thank you guys for joining us. I will see you again. I know that people took a break. I will see you again at 10 if you have the energy, at 10:30. If you have the energy, you can join in. I'll just remind you. Okay, thanks, Ligugu. Okay. Okay, thanks a lot, Ligugu. Yeah, some people told me that the phone was flat, like Ayanda and so on. So yeah. So I'm gonna see you later on if you have the energy. We can meet again because I wanted us to meet. But yeah, just that I'm gonna have a break now. I'm gonna be having another student, grade 7, and then I could return. But 5 to 7, then my load shedding is at 8, so we can't do anything between 7 and 8. It's just 1 hour. Okay, so yeah, thanks a lot. I'll check with you at 10:30. If you have the energy, you can join in. Maybe you're gonna be sleeping. I don't know. Yeah, but thanks. Otherwise, I'm going to be right back again tomorrow morning. I'm going to send you the time for tomorrow morning. And you can suggest for me the times for tomorrow. Maybe, yeah, you might be going to church and things like that. It's a Sunday tomorrow. Okay, thanks a lot. See you around. Okay, and goodbye.
Bye, sir.
Goodbye, Ligugu.